this video, we'll look at some examples of applications that can be solved with linear equations. These are pre-calculus algebra topics, but they may be a review for some students who are currently enrolled in college algebra or pre-calculus algebra course. One type of problem that we get to in pre-calculus algebra are these problems that involve money and investments. You'll see that throughout the set of problems in the textbook as well as on MyLab Math, and we'll look at least one of those types of problems here in this video. Let's look at this first example. This one is even more interesting than investing money. It's about the number of hours that Americans tend to devote to sleeping and watching TV. According to the American Bureau of Labor and Statistics, you'll devote 37 years to sleeping and watching TV. Not 37 years for each, but 37 years total. The number of years sleeping will exceed the number of years watching TV by 19 hours. Over your lifetime, how many years will you spend on each of these activities? We're going to apply the set of steps, a strategy for solving word problems that comes out of our textbook. And the first step is to read this problem and sometimes read it a few times to make sure you understand the problem. One important piece to that reading and understanding is to be able to pull out what the question is. And notice that the question is saying, how many years will you spend on each of these activities? So I'm going to go right through the steps. And number one, I've read the problem carefully. And now I'm going to define x. We're going to let x, or any other variable, represent one of the unknown quantities. So to give you an idea of which one would be better suited for this one, for this problem, in my opinion, it's going to be a little bit easier to let x be the years watching TV. And the reason that I choose x, because you could have chosen x to be the years sleeping, but I chose the x to represent years watching TV because we can read in the problem that the number of years sleeping is being defined using the number of years watching TV. So we could read this, years sleeping exceeds years watching TV. So we could see this x as the independent variable, the one that we start with, and then the number of years sleeping was dependent on x because years sleeping exceeds x by 19. So I'm going to actually state this in writing. Let x equal the years watching TV. And by the way, in your homework log, when you do a few practice problems, you should follow this list of steps each time. If the years sleeping exceeds the years watching TV, then we could say that the years sleeping is the number of years watching TV, x, plus 19. And once we have that, we're ready to move. So that was step 1 and step 2. Now we're ready to move to step 3, where we can write an equation that models the information that we're given. Now, if we keep reading the problem again and again a few times, you see that the total number of hours for sleeping and watching TV is 37. So 37 is equal to years watching TV added to years sleeping. So I can put this in a equation that 37 is going to equal x, years watching TV, plus x plus 19, which was the years sleeping. And now I'm ready to go to step 4, simply solve the equation. And this one solves pretty easily because it's just a linear equation. But let me number this. It's step 4 in case you're looking back and want to review how to use the different steps. But for step 4, I'm going to solve this 37 equals x plus x. I'm going to simplify that to be 2x plus 19. I'm going to subtract the 19 from both sides. I'm subtracting the 19 from both sides because that's how I can isolate the x. So the 37 minus 19 gives us 18. 18 is equal to 2x. And as I continue to work towards isolating that x, looks like I need to divide by 2. Let me show this in color in case anyone's looking back later. You see what I've done to change the equation is I subtracted the 19, and now I'm going to divide by 2. So we get that this 2 divided by 2 is just 1, so we get that x equals 18 divided by 2, or in other words, x equals 9. Now some students make a small mistake of saying, okay, I'm finished, I solved for x. But the problem didn't ask us to solve for x, the problem asked us to answer this question: over your lifetime, how many years will you spend on each of these activities? So we need to finish with the final answer, and that final answer would be, therefore, over your lifetime, we will spend about 9 years. And X was watching TV. And about, if I go back to this total, this 37 equals 2x plus 19. If I put the 9 in for x, where was it? If I put the 9 in for x, then this 19 plus 9 would give us the years sleeping. 19 plus 9 is 28. Write that down. So 28, oh, not hours. That wouldn't be nearly enough for a lifetime, would it? 19 years sleeping. So you want to finish each question with a complete answer. Good mathematical process is to say therefore. I don't know if you're familiar with that symbol. You can just write the word out, therefore, or you could use this neat symbol. It's a triangle built from 3 dots in this shape. Finally, step 5, check the solution in the original wording of the problem, not in the equation, from the words. So let's check to see if this makes sense. 37 years of sleeping. Let me erase some of this extra work here. If it's 9 years for TV and 28 years for sleeping, 37 years of sleeping and watching TV, I could check by adding 28 plus 9, and I verify that yes, that does in fact add to 37. The number of years will exceed the number of years sleeping exceeds TV by 19. So the 28 is the TV years, 9 plus 19, and that verifies. So I can say that I've checked the solution with the original wording. If you find that problem to be difficult at all, I'd encourage you to go back, pause the video, rewind it, go back, look at the problem from a blank page, and try to work through the problem again on your own until you get to the point where you could solve that problem without any other tips or prompts. Let's try another problem, choosing between 2 options for a gym. Gym A offers a membership fee of $40. You pay that one time and then $25 a month. Gym B has a lower membership fee. It's only $15, but the monthly fee is higher, $30. So if we were to let X equal the number of months, because the question is saying how many months will the total at each gym be the same? So the question is how many months. So we're going to let X equal the number of months. If X is the number of months, then we could put this information in a chart, and you see if the monthly fee is $25 if it's $25 a month, then 25 times the number of months, or 25x, would give us the fee that we pay altogether, right? At the end of the time that we've used that gym for, let's say, 7 months. 25 times 7, or the number of months, would tell us how much we've paid monthly total, and then we could add that to 40. So our total would be the membership fee plus 25 times the number of months, or a total of the membership fee of $15 plus 30 times the number of months. So when we move to writing an equation, what we want to do is look at this last statement. After how many months will the total cost, so that's this, be the same? So if we're saying that each of these two totals is the same, what we're going to write as the equation is the 40 plus 25x and the 15 plus 30x are going to be equal. We're going to find x when those two are equal. Let's solve for x. I'm going to move the 25x over to the 30x, so I'll subtract 25x from both sides. And I'm also going to subtract 15 from both sides. So the 15 will move over to the left, and the 25 will move over to the right. So that'll put our x's on one side and the other things on the other side. So if I do this arithmetic, and you are should feel free to use a calculator if you find that you need to, or if that helps you be certain that you're not making a calculator error or a calculation error. 40 minus 15 is going to give us 25. 25x minus 25x is 0. 15 minus 15 is 0. And then 30x minus 25x gives us 5x. And now I can divide both sides by 5 to get that x equals 5. Be careful, because the question isn't asking us to solve for x. The question is asking us to determine how many months will the total cost be the same. So I want to be sure to state that. Therefore, in 5 months, the totals will be the same. You should be able to take this a step further in understanding what this information is giving us. If in 5 months we break even and these two are equivalent, if that's the case, then do you recognize that in month number 6, which of these two gyms is going to be the better deal? In month number 6, Gym A with a higher membership fee is going to be a better deal, right? Because in month 5 they're equal, but every month after month 5 we're paying a lower monthly fee. So if you were intending to join this gym for exactly 5 months, you could join either of the two gyms or either of the two plans, and it would be the same. If you were staying for less than 5 months, we'd be better off paying the smaller membership fee and a higher monthly fee. So you could try this out in the different number of months, see which one comes up cheaper. This Gym B would be cheaper in 4 months, 3 months, 2 months, 1 month. But anytime after month 5, if you're going to stay with this gym for a year, let's say, then the plan at Gym A with a higher membership fee will be a better buy. So make sure, in addition to being able to answer the question and check your solution with the problem, make sure that you're also able to understand what that information tells you or how you could use that information. All right, let's look at one more case with an investment. We've got $20,000 to invest between two different accounts. One pays 1.45% interest, the other 1.59% interest. The total interest earned is going to be $307.50. So how much is invested in each rate? Well, if we let X equal the amount that's invested in account A, then we can find how much is invested in account B by using that this $20,000 is the total invested. So $2,000, not 20. I think I wrote, if you invested, I think I wrote this incorrectly on the, as I was preparing it, because I need one more zero, right? $20,000. $20,000 minus X, the amount invested in the first account, will give us the amount that's left over for the second account. So $20,000 minus X for the second account. Now, the way interest works is we're going to change those percents to a decimal by moving that decimal 2 to the left, or by dividing by 100, 1.45 divided by 100, or just simply move that decimal 2 to the left. We need a zero placeholder. And when we multiply the interest rate times the principal, or the amount invested, that's going to give us the amount of interest. You might remember this: interest amount equals the principal times the rate times the time. We're not concerned about the time right now because the time for each of them is the same. So we don't need to use time. We can just do the principal times the rate. So we would be able to write this total interest earned in each account as 0.0145 interest rate times X, or 0.0159 times the amount invested, 20,000 minus X. And if the total interest earned is $307.50, then we could say that $307.50 is going to add up to the two interest amounts. So I could write this equation: $307.50 is equal to the 0.0145x. Let me show where each of these is coming from. 0.0145x plus the 1.59% interest times the 20,000 minus X. So this 0.0159 times 20,000 give us 318, and then distribute that 0.0159 times negative X for that negative 0.0159X. Work that out yourself also to make sure you are understanding where each of those values comes from. I used a calculator to multiply, and shown the amounts that we get when we multiply here. To solve for X, I'm now going to combine these two X's, and I'm going to subtract the 318. When I subtract the 318, I'm going to get 10.5. And then when I combine the two X's, I get, oh, and this was negative, right? Negative 10.5. And then when I combine the two X's, I get negative 0.0014 times X. So you see, if I divide both sides by negative 0.0014, I can get a final answer for X. And it looks like that gives us X equal to 7,500. Now we're not done yet, because if X is 7,500, we can see there's 7,500 invested in the 1.45% account, but that still leaves us to find how much is in account B. So we would subtract that 7,500 from 20,000 to get 2,500 or 12,500. So therefore, $7,500 was invested in the 1.45% account, and 12,500 was invested in the 1.59% account. I can check those values with the original problem, multiply by the interest rates, see that those two add up to 20,000, and see that when I multiply each of the amounts by the interest rate, the total does come to $307.50. Make sure you follow through with that step 5, and always check your solution with that final answer with the wording in the problem. Let's look at one other type of example really quickly, solving for a particular value or variable. If we're given a formula and we want to find a particular variable, for in this first example we want to solve for P, we can treat the P like a variable and treat everything else like a number. And you see, if we wanted to isolate this P, we would subtract D first. So we would have T minus D equals PM. And then again, if we're solving for P, that's what they've told us to solve for P, what we would next do is divide by M to isolate that P. So it looks like P is equal to T minus D over M. You'll want to try that, practice that a few times. Maybe erase the page or rewind back before there was any writing on the page, and make sure that you could do that example on your own. This next one's a little bit different because we've got to combine two i's first. So we have I times capital R plus I times lowercase r. If we factored that I out, we'd have I times the quantity of R plus little r is equal to E. And then I could divide both sides by the R plus R. So we would end up with I is equal to E divided by R plus little r. And that's how you solve a formula for a given variable. Real quickly, this wasn't in the guided notes in the packet, but wanted to make sure you noticed this important chart in the textbook. You will want to be familiar with each of these formulas and jot these formulas down in your notes, especially any of the formulas you don't already know. So we have A for the area of a square is S times S. Maybe you already know that, you don't need to write it. If it's been a while and you need to refresh your memory on those, then do that. Make sure you're really familiar with a circle. That's a common one that we use. Even if you want to calculate which pizza is the best price at Domino's or Little Caesars or Papa John's or wherever, you need to know that one. And then I'd also highlight these last three simply because these are three that very few people just know from memory. So these three are three that you'll sometimes need to use throughout pre-calculus and certainly in calculus, and not as familiar and easy to find, right? So make sure you've jotted each of these formulas down and are familiar with how to use them. Keeping that in your notes will help you speed through some of the problems in the homework as well. Well, I hope if you have questions, you'll reach out to me in class or send me an email and put a star by the problems that you want to ask about. and we could talk more in detail about any of those.